Hello everybody, welcome to today's lecture. Today we are going to do change of variables. So it's basically change from one coordinate system to different coordinate system. So let us try to understand with an example. So let z be a differentiable function of x and y rectangular Cartesian coordinate system, and let x is equals to r cos theta and y is equals to r sin theta. R and theta are polar coordinates. Prove that. So we need to prove first x is equals to r cos theta, y is equals to r sin theta, right? And z is equals to function of x, y. So we need to prove that number A, which is del z by del r whole square plus 1 by r square del z by del theta whole square is equals to del z by del x whole square plus del z by del y whole square. So let us try to find all these partial derivatives. So these are first order partial derivatives. So let's find. So now del z by del r is equals to, see, first z is a function of x, then x is function of r and theta. So we'll get del z by del x by del r plus del z by del y by del r. So now we differentiate this with respect to r and we get cos del z by del x plus sin del z by del y. Similarly, we find del z by del theta and we get minus r sin del z by del x plus r cos del z by del y, and we take this as 1. Now let us put this value. So del z by del x, so now LHS is equals to del z by del r whole square. So del z by del r is equals to cos del z by del x plus sin del z by del y whole square plus it's 1 by r square. So 1 by r square. Now see, we have r common, so r sin minus sin del z by del x plus cos del z by del y whole square. So let's see. So this will be cos square theta. Okay, there is theta, sorry. Or in all the cases there will be theta. So this is cos square theta del z by del x whole square plus sin square theta del z by del y whole square plus 2 cos theta sin theta del z del x del z del y. And similarly we'll get this r and this r square will cancel because here there is square, and we'll get sin square theta del z by del x whole square plus cos square theta del z by del y whole square plus 2 cos theta sin theta, but here we will have negative because there is negative, sin theta del z del x del z del y. So this and this will cancel, and see, sin square theta plus cos square theta is 1, cos square theta plus sin square theta is 1. So we get del z by del x whole square plus del z by del y whole square, and this is RHS. Hence our first is proved. So we need to show the second option, which is B. And what does B say? Del 2z by del r square plus 1 by r del z by del r plus 1 by r square del 2z by del theta square is equals to del 2z del x square plus del 2z del r del y square. So here we need to find the double derivatives. the double partial derivative, second partial derivative, sorry. So for this we need to write take the operator del r, and it will be cos theta del x plus sin theta del y, and del theta will be minus r sin theta del x plus r cos theta del y. So after this we need to find del 2z del r square. So obviously this is del r of del z by del r, which is del r of cos theta del z by del x plus sin theta del z by del y. Now let's see. So this is theta, so this is out cos theta, and this will be del x del r of del z by del x, and again sin theta, it will be del r of del z by del y, as we need to take theta as constant. We now put the operator, so it will be cos theta, and del r is cos theta del x plus sin theta del y del z by del x plus again sin theta minus r, this is cos theta del x plus sin theta del y del z by del y. So let's see what we get. So this cos theta and this cos theta multiplies, and it is cos square theta, and this will give del 2z del x square, because it's differentiation, partially differentiation with respect to x again, and here we'll get plus sin theta del 2z del y del x, and then we'll get here will be cos theta sin theta, again plus sin theta cos theta del 2z del x del y plus sin square theta del 2z del y square. Similarly, we'll get del 2z del theta square. In the similar manner, we'll get minus r del z by del r plus r square sin square theta del 2z del x square minus 2r square sin theta cos theta del 2z del x del y plus r square cos square theta del 2z del y square, and hence we can write 1 by r square del 2z del theta square plus 1 by r del z by del theta as sin. So this part is going to the left hand side, and we get sin square theta del 2z by del x square minus sin 2 sin theta cos theta del 2z del x del y plus cos square theta del 2z del y square. And now adding this and the above equation, we get the desired result. So this is change of variable, and so we have a homework. Please try this. Hope you'll find the answer. We go on to one more question related to this change of variable. Let's try. A differentiable function f of xy, when expressed in terms of and one more thing that we need to understand is that here del 2z del x del y is equal to del 2z del y del x, because it was differentiable function and hence all the partial derivative exist and they were differentiable. So by Young's theorem we can say that it's the second order partial derivative are equal. So we now go on to next question. A differentiable function f of xy when expressed in terms of new variables u and v defined by x is equals to 1 by 2 u plus v and y is equals to root over uv becomes g of uv. Prove that. So we need to prove del 2z del u del v is equals to 1 by 4 del 2f del x square plus 2x by y del 2f del x del y plus del 2f del y square plus 1 by y del f by del y. So we need to show this. For this we need to find del 2z del u del v. So let's try. So for this we need to find first del z by del u and it's del f by del x by del u del f by del y by del u, and which is so del f by del x by del u. So del x by del u will give 1 by 2 and so this part will be 0 and this is 1, so half del f by del x, and now del f by del y by del u will give root over v 2 root over u del f by del y. I hope you understand the mechanism. It's simple. So we can write the operator as del u is equals to 1 by 2 del x plus 1 by 2 root over v by u del y. So again in similar manner we can find del z by del v, and which is 1 by 2 del f by del x plus root over u by 2 root over v del f by del y. So therefore we need to find del 2z by del u del v, which is del u of del z by del v, and so it is del u of half del f by del x plus root over u 2 root over v del f by del z. So which will be 1 by 2 del u of del f by del x plus 1 by 4 root over uv del f by del u plus 1 by 2 root over uv del u by del f by del y. See, when we partially differentiate this we get half del u of this quantity, but when we go here this will be u by v form. So what we get is we need to differentiate this first. So when we differentiate root over u, so it will be 1 by 2 1 by root over u, which is multiplied here and we get 1 by 4 root over uv, and del f by del y is the same. And in the second case we need to keep this as constant and we differentiate the differential with respect to partial differential with respect to u. So we get this form. Now we put the operator. After we put the operator we have something like this: v by u del y del f by del x plus 1 by 4 uv del f by del y, and later one, which is 1 by 2 del x of half root over u by v del y del f by del y, and hence what we get is, so by simplification we get this half and this half will be 1 by 4 del x, and del f by del x will give del 2f del x square, plus again we'll get half into half is 1 by 4 root over v by u, and then this and this will give del 2f del y del x plus 1 by 4 uv del f by del y, and again here we'll get 1 by 4 u by v del 2f del x del y plus 1 by 4 u by v. So this is u by v and this is v by u, and we'll get this will cancel itself, and we'll get del 2f del y square, and hence what we get is 1 by 4 1 by 4 is common everywhere, so we take it out, del 2f del x square, and now what we see is del 2f del y del x and del 2f del x del y is the same, so we get the sum, which is u plus v root over uv del 2f del x del y plus 1 by root over uv del f by del y plus del 2f del y square, and hence putting the value, u plus v is x 2x and root over uv is y, so we get in this case, and this is the required result. So we get 1 by 4 del 2f del x square plus del 2f del x del y plus 1 by y del f by del y plus del 2f del y square, and this is the required result. I hope you understand. So this much for change of variable. Thank you for watching this video. Thank you for watching this video. For any queries, join my group in the description, and here you can find the soft copy of the notes of the lecture and update of the next lecture. Do like and comment and share with your friends. Thank you.